You have a soccer ball. You kick it at 30 meters a second. My apologies, I probably should have picked 20 meters a second or 30 meters, or it should be 40. There's nothing wrong with 30. The problem is that I also did a 30-degree angle because so many are familiar with 30, 60, 90 triangles. But I probably shouldn't have my initial velocity and my angle the same. But suck it up, we're going to do what we can. The whole point of Chapter 3 is, say, I want you to do Chapter 2, but I would like you to put it in 2 dimensions, the XY coordinate system. I've got this guy flying at 30 meters a second, but I don't want you to think of it as 30. I want you to think of it as he's moving sideways, that's, say, the x direction, and he's moving upward, say, the y direction, to start with. So I don't want you to think of it as 30. I want you to think of it as he is moving at 30 sine of 30 to begin with. And you know what? Let me do an insert page thing here. Okay, there's our initial condition. Let's suppose to say we have a soccer ball which is being kicked. Now, if you kick it straight up, of course, it's just going to come straight back down. It doesn't do you any good. If you kick it on the ground, it's theta is 0. Well, then the other sides are easily going to get it. Okay, we're doing a goal kick here. You're on the 6 yard. The guy backs up about 8 yards, runs, boots it down, goes a certain distance down the field. Of course, the harder you kick it, the further down the field it's going to go. What I would like you to do is be able to figure out how long is it going to be in the air. Let's suppose it was in the air for, say, 5 seconds, just for the sake of it. In the air 5 seconds, and it goes up and it comes all the way back down to the ground. If it started on the ground and it ended on the ground, how far have I gone in the up-down direction? Net. 0. Yeah, I haven't really gone anywhere net. Now look, I realize I really have gone somewhere. I did go a certain distance up, say 50 feet in the air. But then I came back down, minus 50 if you will, and I went 50 minus 50 is 0. I haven't really gone anywhere, so I can look at this as my displacement, which means net distance with direction, in the y direction is 0. And while I'm in the air, I'm going to accelerate in the downward direction 9.8. 9.81, I just rounded off to 9.8 today. So my starting velocity, I'm telling you, is 30 sine of 30, but let's go back to our other page here and see if we can kind of look at that here. Yesterday we discussed that the sine of the angle is by definition the length of the opposite leg over the hypotenuse leg, which in our particular case here is my starting velocity in the y direction. And I am told that my initial velocity vi is equal to 30. So let's go vi sub y over 30 is equal to the sine of 30 degrees, because that's what my initial is. Well, if I plug it in my calculator, I'll find the sine of 30 is equal to 0.50, is equal to vi sub y over 30. So that begs the question, what number divided by 30 is 0.5? And of course, it just rips out for 15. 15 over 30 is 1/2. But let's be a little more mathematically rigorous on this. Let's multiply both sides by 30. And I'll have vi sub y is equal to 15. That means when I'm kicking it at 30 meters a second at a 30-degree angle from the horizontal, what I'm really doing is I'm kicking it upward at 15, plus a certain amount sideways. So this guy over here is 15. Can I get a finger count, please, on how I came up with the initial velocity upward is 15? So recording this here now that we're back live, the horizontal component looks like 25, 26, maybe about 27-ish. The vertical component Get back over there. Vertical component there we found to be about 15. And we said that from the origin to our green dot over here, we said was 30. Okay, had a request to walk through this again. The sine of the angle is 30, right over here, sine 30, is by definition the opposite leg divided by the hypotenuse. The hypotenuse you told was 30. You want to find out how long the opposite leg is. So you have the opposite leg, the initial velocity in the y direction, divided by 30 is equal to the sine of the angle. So let's see here. I've got 30 times the sine of the angle should equal to v sub I. Just multiply both sides by 30. And that works out to be 15. And we physically measured it out. That's 0.5 right here. This is 0.5. So let me look at this other area over here. I'll move the recorder thing up to here. And let's try and figure out what the green arrow is. The cosine of the 30 degrees should equal to my starting velocity in the x direction over whatever my hypotenuse was, which is 30. So if I multiply both sides by 30, I'll find out what my starting velocity was in the x direction. So my starting velocity in the x direction will be however hard the ball was going to start with, or I should say fast the ball was going to start with, 30, times the cosine of, in this case, 30 degrees. So I bust out my calculator and I'll find out what it is. Works out to be 25.98. Which is what I think we had over here. Within our limits of reading here on our scale, sure enough, right here, it's pretty darn close to 26, which is what we expected. Question? Okay, question is, Mr. Duncan, could we have found it via tangent? Could we have said that the tangent of 30 degrees is equal to 15 divided by the green one? Yes, absolutely, you could have. In fact, you didn't actually need to use the cosine of 30. You could have used Pythagorean theorem. You could have said a squared plus b squared is equal to c squared. This you were told was 30. That was the hypotenuse. You already found this guy to be 15. 225 plus b squared is equal to 900. So b should equal to 900 minus 225, all square rooted. And if you punch that in your calculator, I bet you're going to come out to about this. Here's one. Here's a soccer ball. And I want to know how long does it take to reach the top. And people want to do this. And they got this 30-degree thing going on. Well, that's the 30 degrees. If you went to 30 degrees, look, it's going to end up here, but gravity's going to pull it down something. And people are wanting to use Pythagorean theorem and stuff like this when, hello, it's not a triangle. It's a curve. It's more than 180 degrees. Okay, so let's come on back and see what we have to see here. My starting velocity is 30 meters a second times the sine of 30 degrees in the vertical direction. My velocity when I hit the ground, it turns out will be the same speed as I was going up but downward. I would like to figure out how far down the field the ball is actually going to hit the ground. This is you're playing AYSO soccer with the little kids. You know, they're afraid to get it hit, you know, hit it in the head, so they let it hit the ground and then they play it. My key to finding this is how long it's up in the air. Because I know that the sideways velocity, we just found that out to be, is 25.98. So if the ball was in the air for 1 second, it's going to go 25.98 meters down. I need to figure out how long it's actually in the air, so here's what I'm going to do in my upper right-hand corner. for my y dimensions only. And by the way, I will be giving this same lecture again tomorrow and probably on Monday till we get it down. Okay, today's kind of like a preview thing, and then we're going to do it again, we're going to do it again, we're going to get it down. My change in elevation, let's just say my change in y, it started on the ground, ended on the ground, was 0. My acceleration is minus 9.8. By the way, what's making that 9.8? Gravity, excellent. And how much does gravity pull you sideways? It doesn't. That's why the acceleration is 0 in the x direction. But anyway, coming back to our equations up here in the upper right hand, it should be half of minus 9.8 t squared plus 15t is equal to 0. Bring the minus 4.9 t squared to the left-hand side, it becomes positive. I can cancel out a t. Solve for t. It's in the air for 3.06 seconds. Now that I know that the ball's in the air for 3.06 seconds, all I have to do is figure out how fast it's moving sideways, which we already did, 25.98, multiply it by 3.06, which we did. You have it here in red. And if I did my math correctly, it's 79.53 meters down the field. That's quite a kick. That's going goal kick almost over to the other guy's penalty area. 30 meters a second is, I figured out one time in miles per hour, 65, something like that, miles an hour. That's quite a kick. If you're going 65 miles an hour down the freeway and you put your face out the window, I don't recommend it, unless you happen to be a Labrador Retriever or something like that, but you know, it's a different story. But you put your face out the window, you're feeling a lot of air resistance. You take a soccer ball, which is, you know, close to the size of a kid's head, it's a lot of air resistance on it. So it's going at like 65 miles an hour as soon as it leaves its foot. You know, but after it's traveled a little ways, air resistance is going to slow it down quite a bit. So it's going at 25.98 meters per second sideways to start with. But after it's gone a short distance, it's slowed down quite a bit. You know this if you played soccer and the other guys have a direct free kick, and you end up forming the wall thing. You get 5 guys up there, and they're all kind of standing like this. And you know, the guy kicks it, and he kicks it straight at you. You know, it bounces off your legs like, ooh, that kind of stung. But if it's gone halfway down the field, it doesn't hurt so much. It's slowed down quite a bit. So in theory, with no air resistance, it would go 79.53 meters downfield. But reality, it's going to be significantly less than that. Walk through the steps again. Split your x and y components. Start out with y, because you need to find out how long it's in the air. You want to start with y because you know what s is. You know it's going to end up back on the ground. So it's one additional piece of information that you have. Write out SATVIF. Step 3, write down your knowns and your unknowns. Step 4, guess an equation, which we did in the upper right-hand side here. S equals 1/2 AT squared plus VIT. We're only looking at the y dimensions. Step 5, plug and chug, solving for the time. Then now that you have the time, you can plug it in for the x dimensions, which I did in red. Cha-ching. There you go. Question? You get 79.50. Did you actually do 30 cosine 30 times 3.06? Or did you do 25.98? And so you end up with a slightly different answer than mine. It's just a question of how many numbers we kept in the calculator. What did you put for your time? You 3.06 for your time? Okay, when I actually worked this out for the time, I kept the numbers in my calculator. We had time as 3.06. It's not actually 3.06. It's like 3.06, da, 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 and that little extra da, 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 is enough to give you just slightly more. So if I were grading this, what I would do is I'd say the answer is 79.5 plus or minus a little bit on that 5. 79.4, 79.5, 79.6, good enough. That's still allow for that little round off there. Sometimes I have to go plus or minus 0.2. It just depends on the problem. Other questions? It's a great question. Okay, tomorrow I want us to be able to do this problem. It's similar. I think it's actually kind of easier. But it's a little different, but it's similar. This one, you're on top of a table and you're rolling something off and you want to know where to put the trash can in order to catch it. Whereas our other one, you come out on flat ground, but you end up having an angle. This one here, you start out flat, but you end up down at a lower elevation. Ultimately, what we'd like to do is kind of put both of those together, where you have a change in elevation and you start out not going flat. So the first one, we start out with flat ground, but you had an angle. The second one, you have no angle, but you don't have flat ground. The third one, you're doing both. Okay, so you've got to combine those two. This one's a little bit more tricky. And so we'll work that out. Okay, I've got a question for you. Andrew, how long you lived in California? 16 years. Your whole life? Great. Stan, so you went to kindergarten here? Great. That's all I wanted to find out. I assume you know the ABCs.
Yeah.
Please, in 5 seconds or less, say the ABCs.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z.
Very close, but you said them incorrectly. Try again.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P.
I'm sorry. Could you take it, please, from H? Go ahead.
H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X.
Did you guys hear the difference? Do it quickly, starting from G. G, H, I.
G, H, I, J, K, L, M, N, O, P.
What the heck is elemental? Elemental? I mean, I know what a minnow is. It's a small little fish, right? A little minnow. What's elemental? I assume you learned it by singing it. Go ahead. Come here.
H, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q.
Here, let me sing it for you. He doesn't know the words. He's messing up the words. Twinkle, twinkle, little star, how I wonder where you are, or what you are. Up above the world so high, like a diamond in the sky. There are too many syllables. L-M-N-O-P, da 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 da. It's the same song. You learned it via music if you went to the United States. But what's really fun is to talk to somebody, say, from Sri Lanka, who's only been here for 6 months. They didn't learn it via Twinkle, Twinkle, Little Star. So they don't do elemental. It's kind of interesting. There is no substitute for repetition. I know how to shoot a basket. I'm horrible, but I know how to do it. Elbow pointer at the basket, you want to form a plane between your shoulder, your elbow, your wrist. You take your wrist and you twist it all the way as far as you can to the right, assume you're right-handed, and you throw. Doesn't mean I make it. But the reason they have to shoot and shoot and shoot is to teach your muscles memory. So then you get up there. If you're good, you don't even have to look. Not if you know what you're doing. I mean, what, the basket's moved? You go up there, you look, make sure your feet are at the right place, close your eyes, and in theory, you should be able to do 30 of these in a row, in theory. You know, kind of like that little, I don't know, wax on, wax off, little Shogun thing, Zen thing going on, and you kind of shoot the arrow, and then shoot the arrow and split it again. In theory, you should be able to do it. In theory, what you need to do on these guys is do them again and again and again, and then do them again. Then when it becomes boring, do it twice more, to where you don't even have to think about it, it just flows. If you do that, you get an A. If you have to sit and think about it, hopefully you get an A. I should hit